All right, thank you for joining us today. And in this video, we are going to talk about elasticity of demand, inelastic, elastic, and then different kind of question that we are going to go through together, right? But before we start, let's look at this small note that I've compiled for you guys to, actually know what we need before we start the discussion sheet, right? So we know that the elastic at price P, or the elasticity at P, the formula is this, or this. Any of them is right. So we use this when they've given us F of P. We use this when they've given us Q, without saying that Q is F of P. But actually, Q is the same as F of P, as I even wrote it here. So we will get back here. And then we have a question where they've given us a table, and for us to calculate for elasticity, we need to use the change in quantity over change in price times price over quantity. So this one too is the same, because this is when you use the limit definition, you are going to have something like Q prime, right? And you can see P and Q, minus minus, right? So this is one thing that we also need to have it off it, the formula for the elasticity. Now, another thing that we need to know is expected percentage change in demand is equal to, when you see something like this, I define it here, we call it change in price, or price change, right? So the percentage change in price times the elasticity, what you are going to get after computing this. So that one too we need to know. Revenue is equal to price times quantity, which is the same as P times Q. Now, if you want to calculate for the new price when they've given you the old price, so you are saying that old price plus change in price times the old price. So this one is like you having something like A plus XA, right? So I'm assuming that this one here is the X, and then this is the old price. So you see that I can factor A out, and I'll have 1 plus X, right? So that's the idea. So I factor old price out. So when I factor this one out, this one will be 1 plus, when I factor this one out, it will be left with this one. So I will show you how we are going to do this in the examples that we are going to take. Right. So this happens when we are using the addition when it's talking about increasing or increases. And then the same thing here, by here, oops, this one's supposed to be minus. This one's supposed to be minus. So this one is talking about when the function is talking about decreases, right? Or decreasing, right? So this is how we are going to also need to do that. Now we use our new price, either this or this, to compute the new demand and the new revenue, right? Another thing that we need to learn is a change in price. If you want to know the change in price, then the previous price minus the current price, right? PP and then CP. And then change in quantity demanded, or the demand, is previous quantity minus the current quantity, which is also going to give us the change. So we will take example and then we'll practice on that. P is the price. Q is the same as the F of P, is the same as the demand or the current demand. Then this is the change in price, as I said, and this is the elasticity. So this is the everything that we need. So if you want to take a screenshot, I just want to minimize it for you to see it so that you can take a screenshot. Yes, so that you can use it as we are going to the video. Right. So now that you are done, I can do it this way. We can take screenshot like this and take screenshot also here like this. So now let's start. So we have the elasticity when it is less than 1 or in between 0 and 1. We call it inelastic. It means that price increase will increase the revenue, right? And then when it is greater than 1, we talk about elastic. Increase in price will decrease the revenue. And when it's equal to 1, which is the unity, then revenue is at its what? Maximum. Then this is the interpretation whenever we are looking at, maybe if we are done and we need to interpret it, right? So let's go through by applying what we've learned, right? So now what is this given Q or P. So this one, they've given us P or Q, so we can use any of them. We can either use this or this because any of them is right, but we are going to use the one with the f of x. So we know that, let me write it here, E of P is equal to minus P times f prime of P divided by f of P. Right. So given this formula, our function is in terms of P, so we are not worried about this. We have f of P, which is also here. So only thing that we need to look for is we need to look for f prime of P. So what is f prime of P? Now, this can be written as 50 minus P1 over 2. So I change the root of P to P to the power 1 over 2, which will help me to find for f prime of P. So what is f prime of P? When I differentiate 50, I'm going to get 0 minus, when I use this, remember we started how to differentiate and we talk about radical and we talked about the power rule. So here we need to use the power rule. So 1 over 2 drops down, P, then 1 over 2 minus 1, which is going to give us minus 1 over 2. So this is going to give us minus 1 over 2, P minus 1 over 2. So this is the P prime, f prime of P. So what will be our E of P? E of P is equal to minus P times f prime of P, which is this here. So minus 1 over 2, P minus 1 over 2, divided by what is f of P. F of P is this or that, any of them is right. So 50 minus root of P. So this is what I'm going to get. So let's try and do some small simplification and then we are done. So minus times minus is going to give us positive, right? So you're going to have 1 over 2. Now P to the power 1 times this is like P times P to the power minus 1 over 2. This is to the power 1. Indices, if the base are the same, we add the exponent. So P 1 minus 1 over 2, we are adding. So 1 plus minus 1 is the same, minus half is the same as 1 minus half, which is going to give us P to the power 1 over 2. So this is going to give us P 1 over 2 divided by 50 minus root of P. So we can leave our results in this form. We can just leave it like that. Now the next question is, we need the elasticity at P is equal to 100. So E of 100 will be equal to, so since we have this one here, we plug it inside this. So you are going to have 1 over 2, 100 to the power 1 over 2. Now we can write this one too as 1 over 2. P of 1 over 2 is the same as root of P divided by 50 minus root of P. So that I can write this one as half times 1 over 100 divided by 50 minus 100. So root of 100 is 10. So I'm going to have 2 times 10 divided by 50 minus 10. And 2 times this one will be 5. And then this one is going to be 40. 5 goes to itself 1 and goes to 48. So that is what I'm going to get for this one too. Right? So see, suppose a price change of 2.5 is necessary. Use the elasticity function, which is this one, to determine the expected percentage in demand that is expected to result from this price change. So as we said, the expected percentage change in demand is the change in price times the elasticity, right? So we saw that now the change in price here is 2.5%, and this is the same as, don't forget, this is the same as 0.025. So the percent is like, okay, so let me write this one again. This one is like 2.5 divided by 100. So I need to move 2 times 1, 2. So I'm going to have this one to be 0.025, right? Then I need to multiply this one by the elasticity, which is E of P, and this is going to give us 0.025 times 1 over 2. And I think we need to get something like, let me use my calculator. So we need to get something like 0.003,125, and this is the same as 12.3125%. So this is what we are going to get for the expected percentage change in demand due to the change in price. Right. So now the next thing that we need to do is at price 100, what is the current demand and what is the current revenue? So remember we said the current demand is the same as Q, which is the same as F of P. So F of P is here. So since we have the price to be 100, then F of P, which is equal to what is equal to 50 minus root of P, then F of 100, what is the price, will be just 50 minus root of 100, which is going to give us 50 minus 10, and we are going to get 40. Right. And don't forget, this is the same as the quantity Q, right? Don't forget, it's the same as Q. Right. So now what is the current revenue? We know that the current revenue, so this is the current demand, right? The current revenue, we know that revenue is equal to price times quantity. So price times quantity. So what is the price? The price is 100 times what is the quantity? The quantity Q is this, but we need to fix in the P, which we've done that and we had 40. So I just need to multiply by 40 because I had my Q to be equal to 40. And this is going to give us 4,000. So this is the current demand and this is the current revenue. Now, if price then increase, good. So if price then increase, so we are looking at increase here. Then the question is, calculate the new price, the new demand, and the new revenue. So from the tips, we said new price, this is increasing. So we can use this formula to calculate the new price. We are going to use the new price to calculate the new demand and the new revenue. So let's see that. What will be new price? So we're saying that new price, we are saying that new price is equal to old price 1 plus the change in price. Right, that's what we learn from here, right? So it's either you find the percentage on the old price and come and add it to the old price, or you just pick it like this and just add 1 to this. So we are going to have, what is the old price? 100, right? And then 1 plus, so what is 2.5%? 2.5% is 0.025, which is going to give us 100 times 1.025, and when I multiply, this is going to give us 102.5. So that's what you are going to get at the end of the day. Yes. So this is the new price that we are going to get. So since we have gotten the new price, then what do we need to do again? We need to use the new price to find the new quantity demand, or the new demand, and then new revenue. So what will be the new demand? new demand will be equal to, so we know the demand equation. This is the demand equation. So all we need to do is we need to plug in the new price. So we are going to have 50 minus root of the new price is 102.5. Right. And then this is going to be, I think when you fix it on a calculator, you should be able to get something like 39.876. So this will be the new demand. Then what will be the new revenue? So new revenue will be equal to price times quantity. So new revenue is equal to new price times new quantity, right? So this is the new price, which is here, and new quantity, which is also here. So what all we just need to do is we need to multiply 102.5 to 39.879. And this is going to give us 4087.27 when you put it on a calculator, right? So that is how we find for new price, new demand, and new quantity demanded, right? Now here is the same thing to this, but here the only thing is this is decreasing and this one was what? Increasing. So what is the decreasing aspect? So with the new price here, we are going to have old price, and this is going to be 1 minus the change in price, right? So the same thing, this will be 100, 1 minus 0.025, and this is going to give us 100 times. So when I subtract this one, I need to get something like 0.075, right? 75. So when I do that and multiply it by, let me say, 100, I need to have something like I need to have something like, I think this one's supposed to be 9. Yes. So I need to have something like 7.5. Yes. So this is what I'm going to get for the new price when it is decreasing, right? So you see that the price has decreased. So what I need now is so I write it here, I need new demand. So the same thing, I use the demand function, but I just plug in price is equal to 97.5. So I'm using my demand function here, 50 minus root of p, but p is the new price that we are talking about. So this is going to be on the point in the calculator, we are going to have something like 40.125. So you can recheck it for me and see if it is right. Then what will be the new revenue? New revenue will be equal to price times quantity. So new price times new quantity. The new price here is 97.5 and new quantity is 40 times 40.125, which is going to give us something like 3912.26 at the end of the day. So this is what you are going to get. Good. So this is what you are going to get for the III. So let me just fix this one up here small so that I can fix this guys here. So I can talk about D. Do your results back up the table, which is should we do for better revenues, increase or decrease the price from 100? So now let's look at what we are trying to say. So when we decrease the price, what happens to the revenue? So this will be the revenue. When you increase the price to, this will be the revenue. But look at the current revenue when the price was 100. So when price was 100, we had the revenue to be 4,000. So when we increase the price, revenue also increases, right? And when we decrease price, revenue decreases. So this is the original revenue. When we increase the price, we had this one to be the new revenue, and when we decrease the price, this one was this. So what you are going to say is we can just say that we can base on the elasticity, which is this. So since the elasticity here is less than 1, we can see that it's less than 1, then probably we need to increase the price so that we can also increase what? Revenue, because our elasticity is just within 0 and 1. So we can say that yes, elasticity was 1 over 8. So we saw that, right? So we are in what? We are in an inelastic situation, right? Something like that. So as I was saying, we are in the inelastic situation. So what we need to do is we need to increase price so that we can increase revenue. So we need to increase price. So increasing price increased revenue. Increasing the price increase the revenue, right? So anytime you increase the price, we are also going to increase revenue because we are in the inelastic situation. So that is the idea. This is how you can also do the conclusion from there. Now let's look at 2. 2 also follow the same procedure, right? So what I'm going to do is I'm just going to leave the 2 for you. So what you are going to do is the same thing, right? Okay, so let me do the differentiation for you and then you just go through the same thing. So here for the elasticity, E of P is equal to minus P F prime of P divided by F of P, right? So this is the formula for calculating elasticity, right? So if this is the formula, then what is F prime of P? So this is what you are going to use. You are going to use a chain rule, right? So we are going to start with the power rule. So I have 3, which is a constant multiplying. So I'll factor it out, which will be left with P minus 55 squared. So use the power rule. I drop the 2. I maintain the whole function. Subtract 1 times. Then I take the derivative of what is inside the parenthesis with respect to P. So P minus 55. Close. So what did I do? 3 is a scalar, is a constant multiplying the function. So I factor it out. Now I want to use the power rule to differentiate this before I think about the chain rule. So 2 drops down. I maintain the whole function, subtract 1 times the derivative of what is inside the parenthesis. So this is going to give us 3 times 2. Then this will be P minus 55. When I differentiate this, I'll get 1. When I differentiate P, I get 1. When I differentiate 55, I get 0. So this is going to give us 6 P minus 55. So this is what I'm going to get for P prime. So what will be P of E of P minus 6 times P minus 55 divided by 3 P minus 55 squared. Right. So what can I do? Can I do something? Yes, of course I can do something. So this one can be written as minus 6P P minus 55 divided by 3, then P minus 55. So this one I can cancel because this one is multiplying this, and then this one too is multiplying this. So since this one is squared, I can cancel this and this. I can cancel 3 and this. So I'm going to have my final form to be minus 2P divided by, so let me just push it up small. Oh, let me push this one up small so that I can push this one to up small. So minus 2P divided by P minus 55. So what did I do? 3 cancel 6 two times, which will be left with a minus and then the p. This one of them will cancel this. So the top, this one will just go and this one will be left with 1. So this will be the E of P, right? So you see the way it is in the simplest form. So the rest, I think you can do it. So this one is going to be P of 25, which will be minus 2 times 25 divided by 25 minus 55, which will be equal to minus 50 divided by, I think this one should be minus 30, I think so. And this one should be 5 on 3, right? Then you continue the same thing, right? So we have a price change here. This one, the question did not ask us for the change in percentage change in demand, but still, if you want to do it, you can just find it and do 3.5% times the elasticity, which is E of P, which is equal to so the price there is 25. So this one should be 25, which is 3.5% of 5 divided by 3, right? So you can just do it from there, then you continue, right? So I'll stop from here so that you can do the rest. So the rest is depending on everything that we've done here. Now here, increase price. So look for your new price, right? New demand, new revenue. Same thing. This is decrease. So look for new price, new demand, and new revenue. Follow the same example there, and then conclude based on everything that we have done. Conclude checking. So first you can check if this is elastic or inelastic, and then you can base on that to do that, right? So I can tell you that this is elastic because this is 1 point something. So when you are doing your conclusion, you should be careful here, right? So follow the same thing to do that, because this video is going to be long, so that I can also focus on the third one. All right. So with this one, I think what I can do here is I'll create a table which is going to consist everything. Then based on that, we can actually answer all the questions that we need to answer on this question, right? So I'm going to create a table. Right? So let me create a table here. We are going to use it to answer everything. So the table will go with the price. So we have the price and we have the quantity there. So all I need is I need revenue. So I'll create a revenue table, right? I need the revenue. I need change in price. I need change in quantity. So you see what we need. And then I need the elasticity. So these are the things that we need. So how many? 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5. Good. So 1, 2, 3, 4, 5, 6, 7. Good. So how do we find revenue? We know that revenue is equal to price times quantity. So all we are going to do is all that we are going to do is multiply price by quantity, price by quantity, price by quantity, and we are going to fill this table. So that is the price times revenue, right? So that's what you are going to get for price and revenue. So let's do that. What is this times this? We are going to get same thing, 2765. What is 1.25 times 2310? So I'll just try and fill them into 7.5, and then we have 2970.0, 2817.5. Then we have 2, we have 2350.0, and then we have 1800.0, then we have 1075.0. So that will be the revenue. You can confirm. So multiply everything, and you should be getting something like this. Now, what is change in price? So we said that change in price is the current price minus previous price. What did I say? Previous price previous price. No, I've changed it. So it should be current price minus previous price. Yes. So something like that. So I think this one should come here, and this one should be here. So current price is like now, right? And then previous, but okay, so this one should be CP. So this one will be CQ and PQ. Good. So that's what you're going to do. So what are we going to do here? Change in price is this minus this. So this is the current. So if we are here, we are the current. We go to the previous, current, previous, current, previous. Yeah. So this minus this, it is going to be 0.25, 0.25, 0.25. So I think all of them are going to be 0.25. Yes. So that will be the change in price. So 0.25, 0.25, 0.25, 0.25, 0.25, 0.25. Here we are not going to have anything here because when you get here, we don't have any information here. We don't know the next price. So we don't know the next price to do the subtraction, right? Now quantity 2 is going to be this minus this, this minus that, this minus that, this minus that, this minus this minus that. So what are we going to get? I'll fill the table. We are going to have minus 455 minus 330 minus 370 minus 435 minus 375 minus 370, and okay, so here too we don't know what we are going to get here because we don't know the previous price. Good. So that is the change in quantity, change in this. Now don't forget, we remember that I said the elasticity is equal to minus change in quantity divided by change in price times price, price over quantity. So that's what we had here. So anytime they give you the table, this is how it's supposed to go, right? So what you are going to do is, for us to get what is here, this divided by this times price over quantity. So the first one will be like, if I want to fill the first one, this is what I'm going to get. So let me try and clean this one out. Mhm. Let me extend the line small because this one will come with decimals. Good. So the first one will be like, this is going to be, so what was the price? The price is $1. So we are going to have minus quantity is minus 455 divided by change in price is 0.25 times price, which is 1, divided by the quantity, which is 2765. So that's what you are going to do. So change in quantity is this divided by change in price, which is also this, times price, which is this, divided by quantity, which is also this, that's what you are going to use to fill this. If you come here, quantity divided by change in price, price divided by quantity minus, then you use to fill them in. So let's try and fill them out. So 0. I'll just keep them short. Okay, 0. Let's say 6. Let me say 658. 0. Let's say 714. The next one will be 1.121. Then the next one will be 1.891. The next one should be 2.553. Then the next one should be, let's say, 4.1625. We don't have this one too. Good. So this is what we are going to do whenever a table is given and we need to calculate for everything. So now this is the table that we are going to use now that we are going to look for the questions, right? So this one is using the subsequent price and demand, estimate the elasticity of demand at the price $1. So what is the price at $1? That's the first row, right? Because if I want to write the price and quantity, this is the price for this good. So for $1 is at this price. So it means that for the estimation, the elasticity at $1 is equal to 0.658. So this will be the elasticity for this, right? So the question is also asking, at this point, is the demand elastic or inelastic? So you can see that this is less than 1. So we can say that it is what? Inelastic. So let me even create a column for those kind of things, right? So we can have something like this. So this is inelastic. This is also inelastic. The rest are all elastic. So elastic, 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 because they are all greater than 1. Right. So we can see that at A, the function is this, and it is what? Inelastic. Good. At B, we are looking at the price at 2.25. So what is 2.25? 2.25 is the last but one column here. So that is what is here, right? Because 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right? So that is what is here. So here the elasticity at 2.25 is equal to 4.1625, and we can see that. What do you notice? Elastic. Give an explanation. It's because this is greater than 1. That's all. So that's what you're going to get from there. Now find the total revenue. Find the total revenue at each price shown. For what price is the revenue maximized? So I think this table should even come here, because this is where the question is asking us to find the total revenue at each price. So total revenue at each price is what we are having here. So we put it here. But the question is saying that for what price is the total revenue maximized? So let's look at the highest revenue. Okay, so the highest revenue will be somewhere here. So this is where we are going to have the highest revenue. This row, right? This row. So this is the row that we are going to have highest revenue. So highest revenue 2,970, 2,970, and then we have it to be the price is the elasticity is 1.121, and it is what? Elastic. So that is where the price is going to have, or the revenue will be at its maximum, right? Because it was increasing, right? So it increased from this side to this because they were all inelastic, right? And then it got here and started elastic. So it means that it will get to its maximum and it will start dropping down. So that's what we are going to get from there. So I think basically that is what we are going to do from this question here. Now let's look at the 4. Now we have a linear function shown by this, and we have this function here. Explain why this formula works. So let's try and prove that. So if this point here is P naught and Q naught, then this is like S coordinate, Y coordinate. So here is like Q naught and here is like P naught. So it means that here we have P naught, right? And then at this point, X is B and Y is 0. So it means that at this point we have B. So at this point we have B. And then at this point too we have Q naught. And at this point we have A. Good. So what is the formula for finding what's the formula for finding elasticity, right? So we know that the formula for finding elasticity is equal to minus P F prime of P divided by F of P. Now, what is F prime of P? F prime of P is actually the slope, right? So we need to look for the slope of this line, right? So we need to look for the slope of this line. So what are the 2 points on this line? So the 2 points on this line is this and that. So we have one coordinate 0A, another one B and 0. So how do you find the slope? Slope is equal to changing Y over changing what? X, which is y2 minus y1 divided by x2 minus x1. So this is going to give us, if I'm using this one to be x1, or let me say y1, y2, y1, x1, and this one to be y2, x2, then I'm going to have a minus 0 divided by 0 minus b. Is that right? Yes. So this is going to give us minus a over b. So this will be the slope. So the slope is minus b over a. So now, since we know the slope, we can actually say that this is the slope. But what we need to do is we need to look for the equation of the line, which will help us to get the equation of the. When we get the equation of the line, we can name it the quantity demanded. So what is the equation of the line? Y minus y1 is equal to the slope, and then x minus x1. So if I pick any of the points, for example, if I decide to pick this point, right, or let me say if I decide to pick this point, then I'm going to have y minus 0 is equal to minus a divided by b x minus b. So this will be y is equal to minus a over b x plus a, right? Because this will cancel this. Minus minus will be positive. We're left with this. So now this function here, because I want to make sure that it suits this, then I'm going to name this one f of p, and then this will be minus a over b. Then the x there will be p plus a, right? So that I'll get my function, right? Like my function of this form. So now this, since I have this one, then what is f prime of p? F prime of p is actually the slope, which we had it to be minus a over b, but you can decide to also differentiate. When I differentiate a with respect to p, I get 0. When I differentiate this p to be 1, so it will be left with the minus a over b, which is the slope that we found. So now that we have gotten this, we can try to put them in. So minus p times the slope, which is minus a over b, divided by the equation here. So we are going to have something like minus a over b p plus a. Now what can we do down here? Now we can do a lot of things here. We can say that the top is going to be p times a divided by b divided by, so I'm using this divided by like this, divided by the top can be written as, I can factor a out, right? So when I factor a out, I can factor a over b out. So when I factor a over b out, I'm going to have Inside we'll be left with minus P plus 1 plus 1B, because if I factor A over B out, here we'll be left with this. Here we have the A here, but we don't have the B there, right? So I need to make sure that I have B here, so that when I multiply this one by this, B will cancel the B and it will be left with the A. Now what can we do again? We are going to have, so let me write this one well, like this one divided by B. So this is going to be PA divided by B times B divided by A. The one in the bracket, I can write it like B minus P. Then now B will cancel the B, right? A2 will cancel the A. So I'm going to have something like P divided by B minus A. Right, right. So this is my E of P, right? We want to see that this is equal to this. So we can see that this is into P naught. So now let's plug in P naught. When I plug in P naught, I'm going to have P naught divided by, I think this one's supposed to be P, yeah, because there is P here. P naught divided by B minus P naught. Now we can see that what is P naught? P naught is like this distance, right? Because from this to this is P naught. So this is like D1. So we are going to have the D1 here divided by, now what is B minus P naught? This distance here is B minus B naught, P naught, which is D2. So this is going to give us D2, which is what we have here. So that's the reason why the formula works, right? So this is what you are going to get right there. So this will be the solution that we are going to get for that. Good. So now the next question is, determine the price at which the elasticity is greater than 1 and less than 1. So for less than 1 or for greater than 1, now what is the elasticity? We found the elasticity and we have gotten something like this. So we are using this instead of this. We have something like this. So we are going to have P divided by B minus P greater than 1, because this is equal to this. So we replace it by that. I multiply this one by B minus P, multiply this one by B minus P. This will cancel this. So I'm going to have P is greater than, when I multiply this one by 1, I'm having B minus P plus P plus P. I'm going to have 2P is greater than B, and P should be greater than B over 2. Right. So the price should be greater than this, so that I'll have elastic, right? Now, for me to get this is just simple. Since the price is greater than this and I'm getting elastic, then it means that when the price is less than this, I'll get there. So for E is less than 1, P should be less than B over 2. So if you want to solve it, it's also the same thing. You pick E is P over B minus P, which is here. Then it should be less than 1. And then this is going to be, you multiply through by B minus P. So P less than B minus P. Like the same thing that we did here. But here the sign was greater than and this is less than. So when I add plus P on both sides, I get P less than B and P is less than B over 2. Yes. So that's what you are going to get for the B. Let's do the last question. Let's do the last question and then we are done. So the last question is going to be based on what we are just doing here, right? But with numbers, right? So this is the last question. This is a question 5. For each of the following demand functions, find the elasticity function and determine for which price will an increase in price will increase the revenue. So don't forget, Anytime we talk about increase in price, increase in revenue, we are talking about the inelastic, where um, E of P is less than 1. So that's what we need to do. So everything that we are going to do here is, first we need to calculate for the elastic before we can determine the price. So 4 of them, let's go through quick. So first we need E of P. E of P, since this one is scale, we can write this one as minus P. So as I said, this one can be written as either F prime of P or Q prime. So since this is Q, I'll write it Q divided by Q, right? So this is what I'm going to get for the function. So this one I need Q prime, which is going to be minus 8. So when I differentiate this, I get minus 8. So E of P will be equal to minus P times minus 8 divided by 400 minus 8P. So this one is like very simple. Just know the formula, differentiate, and just do substitution. So when I multiply this, I'm going to have 8P divided by 8 minus. So you cannot cancel this and this unless you can factor 8 out. Yes, of course we can factor 8 out. So here, if I want to factor 8 out, 8P divided by, so I factor 8 out. 8 times 5 is 40, so this one should be 50, so that I will get 400 minus P. So you see, I will be able to cancel it out because I was able to factor 8 out. And this 8 that I'm cancelled out here is multiplying the one in the bracket here. Good. So 8 will cancel 8, and I'm going to have it to be P divided by 50 minus P. If you cannot do the simplification, you can leave it here and you are done. So this is E of P. The next question is asking us to determine the price. For increase in price, also increase the revenue. So we need to think about this. So now E of P should be less than 1. So what is E of P? This. So P divided by 50 minus P is less than 1. I multiply through by 50 minus P on both sides. So I'm going to have P less than 50 minus P. What did I do? I multiplied this one by 50 minus P, multiply this one by 50 minus P. This will cancel this, which will be left with the P, and then this time that will give us what is here. I'll add plus P, I'll add plus P, so 2P will be less than 50. I divide through by 2, divide 2 by 2, so P should be less than 25. So this will be the price that we need. So for example, if the question is saying that price increase decreases the revenue, then we need to think of E of P greater than 1. So that's what we're going to do. So if that was the case, this here should have been P greater than 1. So I'll just change the sign like this, like this, like that. And that's all. Yeah. So that is the first one. If you want to do it, that's the first one. That's what you just need to do. Right? Now let's look at the second one. This one here. So let me shift this one small to this side. Good. So here too, all we need is Q prime. So what is Q prime? We are using the change rule. So 2 down, 2 is multiplying. So I multiply by 230 minus P. I subtract 2 minus 1 times. I differentiate what is inside the bracket, which is going to give us D over dP 230 minus P. Right? So change rule, 2 is here, right? Then 2 drops down. I maintain the whole function here without the 2 because I factored the 2 out. And I subtract 1 times, I find the derivative because the function is in terms of P. Derivative with respect to P inside of the one inside. So I'm going to have 2, this will be 230 minus P, 2 minus 1 is 1, and this one when I differentiate I get minus 1. If we know how to do it, you do it straight. So 2 times 2 is 4 times this one will be minus 4. So minus 4, 230 minus P. So that's what you're going to get. Then what can you do again? Now we need E of P, which is equal to, so E of P is equal to minus P times Q prime, which is minus 4, 230. Or we can try to simplify this, or let's just leave it like that. So 4, 230 minus P divided by the Q, which is 230 minus P squared. So that's what we need based on the formula. So minus P Q prime is here, which is here, divided by Q, which is here. So now what are we going to get? When I multiply this and this, I'm going to have 4P 230 minus P divided by 230 minus P squared. So I can cancel 2 and this because it's multiplying, and I can cancel one of this. So I'm going to have 2P divided by 230 minus P. So this is what I'm going to get for the E of P. Then as usual, I just need to make sure that this is less than 1, then I find for the price. So the same idea, right? Same thing, same idea. So let's go through the process and see how we can get this one to be less than what? 1. So 2P over 230 minus P is less than 1. So I'll multiply this one by 230 minus P and multiply this one by 230 minus P. So this will cancel this, giving us 2P less than, when I multiply the right hand side, I get 230 minus P plus P plus P. This is going to give us 3P less than 230. And then I divide through by 3, and I'm going to have P to be less than 230 divided by 3. So that will be my final result there. Right. So the same process, the same thing you are going to use to do it. So the same thing here, go through the same process, find Q prime, which is going to be easy. This one, Q prime, should give you minus 10P. You do substitution, you find your E of P, and then you are saying that it's less than 1, then you find for P. Same thing. Then with this one, you can use the quotient rule, which you are going to have U over VIN, or because this one is constant, you can convert it to the power rule. So how can I do that? Q is equal to 1000 divided by 2P plus 50 this. So I can write this one as 1000 2P plus 45 to the power minus 2. So this one is like, I've converted it to the power rule, which I'm going to use the chain rule to differentiate. Or you can also use the idea of the quotient rule to do U over VIN. U is equal to 1000, VIN is equal to 2P plus 45 squared. What is U prime? 0, because it's constant. What is VIN prime? I'll do it straight. So 2 drops down, maintain the whole function, subtract 1, which will be 1, then differentiate what is inside the bracket, giving us 2. So this is going to be 4, 2P plus 45. So if you can see something, mostly I don't simplify this because always I'll be able to cancel that. So what will be Q prime? Q prime is VIN U prime minus U VIN prime divided by VIN squared, right? So this is going to be, what is VIN? 2P plus 45 squared times 0 minus, what is U? 100, and then what is VIN? 2P plus 45, all divided by 2p plus 45 squared, all squared again. So fortunate for us, this one goes to 0. So we are going to have minus 400 2p plus 45 divided by 2p plus 45 all to the power 4 because of 2 here, 2 here. Then one of this, we can cancel one of this. So we are going to have the derivative to be minus 400 divided by 2p plus 45 all to the power 3. So this is my Q prime. So let me finish up doing this because I think it's going to be complicated. So what is this? This is going to be minus p times Q prime, which is this one here. So minus 400 divided by 2p plus 45 all to the power 3 divided by Q. What is Q? Q is this. So the divided by, I'll write it divided by 1000 divided by 2p plus 45 squared, right? So what can I do? I can multiply this and this, giving us 400p divided by 2p plus 45 to the power 3. Then I'll change the division to multiplication and turn this one up. So I'm going to have 2p plus 45 to the power 2 divided by 1000. Then 2 of this will cancel 2 of this. And then I think this one we're going to cancel. So we are going to have this cancel itself 10, cancel here 4, 4 here 2, 4 here 5. So the top here will be left with 2. So I'm going to have 2p divided by, don't forget here we'll be left with 5. So I'm going to have 5, 2p plus 45. So this is what I'm going to have. Then what I need to do is, if I want to multiply, yes, I can just multiply it out to get something like 2p divided by 10p plus 90. Then you can do this. So what you just need to do here is 2p over 10p plus 90 is less than 1, then find for p. So I'll do it quick. 2p is less than 10p plus 90, right? So what I'm going to do is I'll add plus. So I'll subtract 10p here, 10p here. So it's going to be minus 8p less than 90. Wow, interesting. So what are we going to get? What I'm going to do is I have minus 8p less than 90. I'll divide through by minus 8, divide through by minus 8. And this is going to be p. Whenever you divide through by minus and the sign is either less than, greater than, less than or equal to, greater than or equal to, the sign changes. So this one will be greater than 90 divided by 8. So this will be the price that we are going to get. All right. So this is the end of the video. Don't forget the tips that I gave you. Have this, you can screenshot it, and then if you didn't understand, you can play the video again, take your time, watch them step by step, and you'll be fine. See you in the next video.